I am giving away another Arduino library which I have written which makes working with arrays safer. I call it SafeArray. What it does is take a raw array and stores information about it so you can use it without worrying about memory corruption from invalid indexes. If you want to download it, you can follow the link in the description underneath the video. Here's the example program to show its functionality. This may differ from the downloaded code as I might add to its functionality in the future, especially if it is popular. Here are three arrays. Message is a simple C-style string, not to be confused with the more modern string object. I have included this just to show you that SafeArray can work with it. Underneath are two more arrays of numbers. The important thing here is that the quantity of values can be unknown to you. You can just simply write an array of numbers without knowing how many you have written, as the SafeArray class will work that detail out for you. Some of you who have worked with templates will recognize the first way of making a safe array of doubles from the raw array of decimals. I also wanted to show you an alternative way of making a safe array if you don't want to explicitly enter the type in angle brackets such as int or char for those unfamiliar with using templates. If you haven't seen the auto keyword before, it tells the compiler to work out the details for you for what has been returned from a function. You simply use the makeSafeArray function by passing the raw array to it, and it makes the SafeArray object with all the details within, and the array of integers and array of chars objects capture all of the information that has been returned. If the compiler ever uses C++17, I can alter this to make it even easier, but as of writing my compiler uses C++14, so I have to use the makeSafeArray function for now. Here we print out the contents of the array of integers object. Note that we have access to a length function and we can use the square brackets as we do normally. Now, to demonstrate the ability of SafeArray to protect memory from corruption, I set the array of decimals object with the value of 16 at index 2, nothing unusual there. This changes the original array as SafeArray doesn't store a copy of the array, it just stores the address and length. Now I try to put the value of 128 into the index at 30, but this would point to memory which is out of range of the array. What SafeArray does is set an internal value instead to protect memory. I print out the array as normal, but notice I add a +10 in the for loop to try to print out invalid memory beyond the array, so don't do that yourself, it's just for demonstration. The SafeArray detects that I'm trying to read beyond the array, so it directs the program to an internal variable instead, which was set to 128. Just to stop memory corruption or the program from freezing. There are set and get functions too. The set function sets a variable and returns a value if you want to see if it was successful. The set function returns a 0 if you set an element in the array successfully, or 1 if there was an error caused by the index being out of range. You can ignore this feature if you want, like in the example presented here. There are two versions of the get function. You can supply it with a value to return if there was an error. Here I've put a +10 in the for loop again to try to get memory beyond the array. When the get function receives a valid index, it returns a value requested, but if the index is invalid, it returns a value of your choice, which in this case is -1. The other version of get will return a value when a valid index is supplied, or it returns an internal value, so at least something is returned. There is a fill function which fills the entire array with a value of your choice, which is useful for initializing the array before it is used or reused. Here, this demonstrates the length function, which tells you how many values there are instead of you remembering how big the array is. I demonstrate that the SafeArray works with the older C-style strings. These are stored as char values terminated with a 0, so the true length is the quantity of characters plus 1. The code prints out each value as before, which in this case are chars. There is a square after the word when you run the program, which reminds you of that final zero in these types of strings. Finally, I show you that SafeArray also works with range-based for loops. I use the auto keyword here for convenience instead of int or other types. I can easily get at all the elements there for printing out individually, which is easier to write than the other types of for loops. So this is the state of the library at the moment, and if I add to it, I will write up the improvements in the example program. As you can see, I've tried to prevent memory corruption from invalid indexes, which is too easily done when using raw arrays. I do hope this library helps you, and thank you for watching.